All right, so this is where we left off last time. We did linear searches, right? First I showed you, we did it with a for loop, we did it with a while loop. Both are really the same algorithm, just the code's different, but the algorithm is the same. And then I added a little modification to the end. Character is at, where I didn't want you to give me a Boolean if the character existed in the string. I wanted you to just tell me which index it existed at. So if I was looking for an H in hello, it would return 0. If I was looking for an O, it would be 0, H-E-L-L-O, index 4. Right, that's what we'd give you back. But then we kind of had the issue of, okay, well, what do you return if, what do you return if you don't find anything? Because it's possible that the value, like the character you're looking for in the string isn't there. What do you return? And that's when I said, well, we could return what we would call a sentinel value, which is just a fancy way of saying return some value that has a special meaning. I mean, it would be important that the value that would get returned is something that isn't a valid response in general. Like, oh, if it ever returns 10, then I know it's not found. Well, what if the thing you're looking for is at index 10, right? Well, there is no index -1. I realize in Python you can index things negatively, but negative indices don't really exist. So if I return -1, that has a special meaning for whoever's using the program, whoever's using the function, that, okay, that means the thing you were looking for wasn't there. And of course, you'd write this in your doc string. And if you wanted to make your code even much more explicit, you could have a constant. So instead of returning -1, I could return not found, which is -1, but perhaps it's got a little bit more meaning in the code, right? The code is a little bit more self-descriptive. Though your average programmer would probably see a -1 in this context and know it's a sentinel value, but there's nothing wrong with being that much more clear about your code. All right, so now for some just string trivia. I'm just going to tell you some things about strings. This is obviously not exhaustive. I'm not going to go into heavy detail on all of these things. Really, I'm just showing you that they exist. So if and when in the future you ever want to do one of these things, you're at least aware of it so you can go look into it more on your own, right? So if you know you can do something, you just don't know how to do it, it's better to know that than to not know if it was possible in the first place. See what I mean? All right, so here, we've got two strings there. They're both strings, but what's the difference between them? Well, the top one uses two quotes, like two double quotes. The bottom one uses single quotes. Now, traditionally speaking, in a lot of other programming languages, strings are always double quotes. Python's the weird one to allow you using single quotes, and particularly because usually, in a lot of other big popular programming languages, single quotes is how you would specify an individual character, is with single quotes. So Python's a little bit the weird one here, and both are valid. Now, there are some consequences of using single quotes versus double quotes. If I use double quotes, let me show you an example. All right? And nothing particularly fancy about that string, right? But if I go and I do this with single quotes, we got a bit of an issue. You see? Now, you can fix it by using the slash, a backslash like that, and it'll work. Backslash is a way to be like, I know this character has special meaning in the code, but I just want it to just leave it alone. So you could do something like that. Regardless, both are valid. But who wants to take a wild guess what I would recommend as the better choice? double quotes. One, it's more general. Two, it's more in line with the other popular big programming languages you're going to come across. Might as well be consistent. There you go. For the most part, I try to use double quotes wherever possible. Maybe in the course content, you'll see I use a single quote somewhere. That wasn't intentional. I just did it by accident. So both are fine. But double quotes is better. It's not, but it is. But it's not, but it is. Yeah?
Can you use like backslash? Does that like literally ignore everything?
Well,
Just in a string
no. So it really depends on the context, right? So here I did the /s, and well, it just represented that as an s. Or sorry, it actually represented the backslash. But when I did it here, it didn't, because it knew, well, in the context of a string, a single quote, you know, it'll just kind of ignore it, right? So Python's doing a lot of extra work here for you. Then this then begs the question, well, what if I really did want the backslash to be right before that single quote? Well, then you do too. So you're basically saying, like, a single one would be like, okay, you know, ignore the fact that this is a string, represent the backtick, right? Yeah, I'll just leave it like that. But now I'm saying, ignore the fact that I'm telling you to ignore the fact that it's a thing, right? That it has any special meaning. So now it'll actually show the backtick. I just had two, just because of the context. If you're worried, if you're looking at this and you're worried, this is very unlikely to come up. Like it's, how often do you write backslash like that, right? In your strings, not very common. Almost always it's when you're doing like escape characters that have special meaning. One of which is kind of interesting, is, check this out. Let me get rid of the extras. Who wants to take a wild guess what that /n did? New line. Absolutely. Yeah. Now be warned. Now this is fine here, and in a lot of cases it's going to be fine. But if you're running, now this is a bit of an aside. I'm just going to say it anyways. On a Unix-based system, so on Linux and Mac, /n is your new line, right? That's like the correct way to do it. On Windows, the correct way to do it is this. Now here we're actually running this, I'm guessing, on a Unix system on the web somewhere, and we don't really see the difference here. But there's a historical reason for this. So here's the, okay, there's actually a lot of funniness about, there is a lot about the way computers work and the way we do things with computers that really are just a consequence of someone's decision a long time ago that kind of stuck. Now, if you go back a long, long, long time ago, and we had typewriters, right? But like, we had like our keyboards and whatnot, but you know, when it was printing, who here's seen an actual typewriter in real life, right? Put your hand up. Raise your hand if you don't know what a typewriter is. You know those things, you tip, you're typing away, and then ding, you know, and you got to go, all right, go back, and you continue, right? It's like a very mechanical way of typing, right? Old way. Well, you know, you're printing things, there was still like this old school, like we had these like digital computers, but they were connected to these like typewriters. I'm simplifying this story, all right? And if you wanted a new line, it wasn't as simple as saying, go to the new line. Because imagine I'm typing, and you gotta think of how the typewriter works, right? I'm typing away, and the little like, the page actually moves. The head of the letters that you're typing don't move other than they go forward and hit the page, right? Right? Raise your hand if you've seen a typewriter. So half of you are happy with this. But like the page moves, right? As you go. So I'm typing and the page is moving. And eventually I get to the end. It goes ding, and I'm out of room on that line. I can't just say, okay, go to the next line. Because going to the next line means, okay, the page has moved here. Going to the next line would be move the page up a little bit, right? No, I need to return to the beginning of the page and go to the next line, right? So there was actually 2 steps there. And so that this /r/n means return the carriage, go to the new line, right? So this really is a consequence of some fun little fact about, back then. There's a lot of funny little stories like this that can come up. I think it would be great. I think it would be hilariously awesome and fun to have a course in computer science that was like the history of computing, which sounds really dumb, but the focus on the course would be like all of the funny little quirks that exist today and why the hell they actually exist today. It won't make you happy about the quirks. It'll just explain why they exist at least. So it doesn't justify them, it just explains them. You can at least understand it. But that's not important right now. Anyways. And so to go back to this /n, which I'm pretty sure I talked about a little later in the topic, /n, that means go to the new line, all right? Because if you say, like, how would I type go to a new line? Right? Well, on your computer, if you're typing in Microsoft Word or something, you just hit enter, right? But that's clearly not going to work here. That's going to mess up the string. So I need a way to tell the string, okay, go to a new line, and that's where we have that /n encoding to mean like, okay, go to the new line. Yeah. By the way, the /r/n versus /n, not so much anymore, because a lot of like computing systems and word processors and IDEs and places where this would come up will be aware of like which operating system they're on, and it'll account for the new lines and whatnot, so it won't really get conflicted. But even when I was doing my undergrad, I remember working in my version of 161 or 162, we had to do a maze solver. And we had to read in the files from a text file. And the hardest part, I spent like days figuring out why I couldn't read in the text file at all. And it was because the file was made on one operating system, and I was using a different operating system, so it wouldn't, the number of characters would get all messed up in each line, and so my maze was all messed up. Those old days, they were terrible. Kids these days, you don't even know how bad it was, right? That's the story. Anyways, this shouldn't be shocking. We've seen this already. You can concatenate strings. Addition, it depends on how you use it. If you use addition on strings, it means stick them together. Here's an example of taking the string CSCI, concatenating it with the string that's just a space, and concatenating that with 161. And if I print it out, I would see CSCI space 161. We can do that. You should all be probably aware of that. You can multiply strings by themselves. If I took the string CSCI and multiplied it by 3, I get CSCI, CSCI, CSCI. Just repeat it 3 times. You can actually convert so here I'm saying, tell me the type of 1. It's going to say int. But I'm saying, okay, take the integer 1, convert it to a string, and tell me its type. Well, it'll be string. Right? So I can convert it. Here's another one. A string that is an empty string, an open quote, immediate close quote, is a string. It's not nothing. It is a string. It's just there's nothing in that string. Which might sound like a nuanced difference that, like, am I splitting hairs? But no, I'm not. There is something there. There is a value there. It's a string. It has a type string. It's just The string contains no information. And this difference is important. But if I ask what's the length of that string, it would be 0. I couldn't index any value at that string because nothing exists in it, but it is a string. What's the type of A? It'd say string. So yeah, here's the /n example. Oops. Who wants to take a wild guess what /t does? Yep, tab. I don't know why I have this extra slash. I just wanted to show you that I would need the slash if I wanted the slash. But /n means go to the new line. /t means tab. Why? Well, I can tab, I guess, because it will show up. But if I wanted to say contain a tab character, there is no tab character for me to press like there is a Y character. So if I really want a tab to be encoded in the string, I say /t. Now here's something interesting. And this is actually very, 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 very related or connected to what I was talking about yesterday. Integers take up a certain amount of space in the computer, right? And each one of those integers fits in one of these seats. Individual characters take up a certain amount of room in the computer, and they also take up the amount of room for a seat. Now this could be 8 bytes, 4 bytes, whatever, but it takes some amount of discrete space, like some unit of space. Now, if I gave you the binary number, let's see. If I gave you the binary number 01100001, let me check that. See if I did that right. 97. Nice. I was right. If I gave you 01100001, right? And I ask you 01100001. First and foremost, you got to remember, computers don't operate on zeros and ones. No. What do they operate on? They operate on low voltages and high voltages. That's it. We can represent them as zeros and ones. Those are bits, right? Everything on your computer has to be representable in low voltages and high voltages in order for everything to work, meaning you could represent them as zeros and ones. So if I ask you, what does 01100001 mean? You can't really answer that question, though, because I can't ask you what it means, because if everything can be represented, let's think about this logically for a second. What just happened there? You traded laptops? It was a weird thing to observe. All right. Did you mix them up by accident? I'm confused. I see. All right. So, if I can, let's think of this. Let's deduce. I can represent anything. If I want to represent something on a computer, it needs to be in zeros and ones. Therefore, if anything can be on a computer, if you have anything on a computer, I see a bunch of you with a computer right now. Some of you are even changing who has them. You're looking at stuff on that computer, and that information must therefore be in the computer somehow stored, meaning that those things are actually represented as zeros and ones, right? Anything we could store on the computer must be representable by zeros and ones. So I can encode anything into zeros and ones, okay? Assuming I can put it on the computer. So if I give you 011000001, and I say, what is that? You can't answer that question unless I give you a little bit more information. If I can represent anything that I can put on a computer in these zeros and ones, the question you have to ask is, well, I can't tell you what that means unless you are telling me what was it encoding in the first place. Was it a number? Was it a pixel? Was it a character? What was it? I can't decode those zeros and ones unless you tell me what the type of thing it was encoding. So if I have 011000001 and I tell you decode that as an integer, the computer goes, that's easy, that's 97. But if I say, no, decode that as a character, as an individual letter, the computer goes, oh, that's easy, it's a lowercase a. The binary number 01100001 means a, lowercase a. It also means 97. That's the way it is. If anything can be encoded as zeros and ones, I have some encoding mechanism. I have some process in which I convert the letter A into zeros and ones. I have a way to convert the color of a pixel into zeros and ones. I have a way to convert integers and floats and booleans into zeros and ones, right? So if I say, okay, I was able to encode a character, now decode it as a character. Decode it as if it was an integer. Now, the reality is someone somewhere had to say, okay, the letter A is 01100001. And then you're going to say, why? And there is some reasoning behind it. This would be an example of something to teach in the history of programming and whatnot. There is kind of a reason for it, but at the end of the day, it seems kind of arbitrary. Who wants to take a guess what 01100010 would represent as a character? Lowercase b. Yeah. How about, now here's the big one, 01100011. You could probably guess it. Lowercase c. Nailed it. But if I tell you to decode those as integers, you're like, well, that's 97, 98, and 99. So the same sequence of zeros and ones can be used to represent different things. It all matters about how you decode it. Am I decoding that as a pixel, a color of a pixel, the value of some integer, some character? It all depends. This all means I can say, ord. I'm not 100% sure. I'm pretty sure this means like ordinal, which just means some ordered number. I'm saying, so first of all, if I say, okay, 65, take the number 65. Remember how if I were to say convert the number 65 to a string, it would give me back the string 65. Here I'm saying convert the number 65 into a character. And if I do, it'll give me back the letter uppercase A. That's what it'll give me back, uppercase A. I could also say, give me the ordinal, basically saying convert this character to an int. It's a little bit of a funny way to do it. But convert this A to a number, it's going to say, oh, it's 97. Because integers, all these things that we would traditionally call like a primitive type, would all traditionally be encoded with repeating patterns that just they get decoded. Ambiguity is resolved based on how am I decoding it. Has anyone in here ever opened up a file as like a text file and then you just see this file, bunch of bullshit characters? Yeah, it's because the computer had encoded, let me see if I can do it real quick. I'm trying to think, can I? Here, Which one's small? I want to see which one's small. These are all still really big. I'm going to see if I can do this real quick. It's probably not going to be happy because these files are going to be huge. But let's see if I can do it. I'm going to open it with a text editor. There. This is what I mean, right? Have you ever opened a file to only ever see something like this? Right? Well, that's because I had a video that is encoded with zeros and ones, and the computer knows how to take a video and store it in zeros and ones. So it took some video information and encoded it as zeros and ones. And then instead of decoding it as those zeros and ones as a video, I said, no, decode it as if it was a text file. And the computer goes, okay, here. That makes sense, right? It's because some of those zeros and ones, when decoded as characters, are fine. But some of them are pretty wild, right? Yeah. This is all a consequence of that. This is what we call an ASCII table. Number sign, oh, that's 35. Right? Makes perfect sense, right? Anyways, ASCII table. Someone somewhere came up with this, and we're stuck with it. All right, F strings. Here's a good one. So you've probably been, like if I said, let me show you here. I don't know what's happening here. Is it running? There we go. Right? So if I wanted to like have some variable information I want to put into a string, I can do it just by concatenating these things. Now, one of the limitations here, I mean, there's nothing wrong with this, but one of the limitations here is if I wanted to do like 1, 2, 3, it's going to be unhappy, right? It's going to say like, look, I can't concatenate the integer 1, 2, 3 with strings. I just can't, right? So I realize you're like, well, why would I convert it to an int? I don't know, maybe I wanted to do like +1, right? And now obviously this is going to be a giant mess. So I would have to say str of that, convert that to a string, and there. And now it's fine. I mean, clearly this isn't too bad. But a couple years back, the good people at Python came up with an idea. I don't know if it was their idea. I think they probably stole it from another programming language called F strings, formatted strings, where you could just do this. It's important to have the F in front. First, notice I didn't need to concatenate strings. I was able to like just say what I wanted in line very nicely. When I concatenated strings, I needed to be sure I had the spaces. I needed to be sure the type was right. This one, it didn't matter. It was an integer, but I was still able to do this. I could add 1 to it right in place. So this is quite handy. And here, let me show you. I'm just going to copy this one. And where it gets pretty handy is you can actually start to, now this is kind of hard to see, there's actually some syntax you can add. Like here I had the float 456.789, and I wanted to print it out, but I only actually wanted it to be 2 decimal places. So I say the name of the variable, colon, point to f. The f, it's a float, whatever. If you want to learn about all these different syntax for all the different variations, go have at it, look it up. But I can do this, really handy right there. I can even like pad the left-hand side, so it'll actually give extra space here, This gets handy if you want to have like formatted text on multiple lines, all like aligned the right way. Right, so here's an example, right? Let's say I was doing a bill calculation, and I realize I've got some literals in these prints, but imagine it's the result of doing all these important calculations, and this is on their bill, and you're like, that's ugly. I don't like that. I mean, if it was a bill, I want everything to be like lined up on the decimal point, right? Then I'm happy. So, I mean, even look, if I've got 1.10, if this is a bill, I don't want it to say 1.1. I want it to say like 1.10, right? I want the sense there and everything. Well, I could do this with the f strings a little bit more nicely by saying, okay, I want that number. It's going to take 8 characters in total, and I want 2 decimal places. So now it's a lot nicer. Right? You agree, this is much nicer to look at. Everyone loves this. They're all aligned. It included the fact that it's just 10 cents, right? I'm not going to go into any more detail on these things. It's just be aware that if you're ever thinking, oh, I've got to format my text, my output text really nicely, just think, I remember he talked about those F strings. I better look into those again. Be aware that there's a way to do it really easily, and if and when you need to do it, just look it up when you actually need it. All I want to do right now is to make you aware of what you could do. I'm not going to go into all the details of how to do all of those things. And obviously this is not exhaustive either, right? It's impossible. Yeah, Cool. Any questions about any of that? Anything? All right, I'm going to warn you. I'm about to piss a lot of people off because we're going to start talking about objects. And there's nothing wrong with them. Just like everything else, each individual thing we're going to learn in and of itself is simple, not trivial. Again, simple in that maybe, it's not too bad, but the complexity comes with how you use it. But objects are going to introduce a bunch of new ideas that might break some of the ideas that we've been following so far. So I'm going to warn you. If at any point you're listening to me when I'm talking about objects and you think, that's dumb, I liked it I'm with you. But it is what it is, all right? So objects. Now, fortunately, I just gave you a big warning, but here's another warning. I'm going to keep it high level right now. We're really going to sink our teeth into objects a little later in the course. I'm going to keep it high level, and what I'm going to say is also not quite accurate for Python. I'm going to be talking about these things at an abstract level about how it works in general, to give the idea of what's going on, to give you the intuition. The underlying ideas being presented below are important. Additionally, more details on objects presented later in the course. Yeah, so this is not intended to be exhaustive. You're not going to be an expert after this. I just want you to be a little bit aware. So, and again, I want to be clear too, what I'm about to say is absolutely not true in Python, but is true traditionally in a lot of other programming languages. And Python will go out of its way to pretend that Python works the same way as the other languages, where really it's not in the back end, but it's weird. Just all of this is to hedge against that student that goes, well, technically, I know that it works. I know. You're not impressing me by telling me that you know that Python actually works a little differently. I know. Just let's pretend it works this way for the sake of argument, to give you the ideas, all right? So we've seen a few types so far. Most are what we would call like a primitive type. Like I just taught, like that ASCII table, the integer, right? It's primitive type. A float, primitive type. A Boolean, primitive type. An individual character, which really isn't a type in Python, but in other languages it is. They're primitive types. The computer is happy with them. They know how much room they want to allocate in memory to store a character or an int. They fit nicely in one of these seats. I'm happy. But strings were different, right? Because how much room do I need for a string? That depends, right? How big is the string? You're going to have a short string, a long string, a medium string. They're all going to need a different amount of space. Unlike the integer, the Boolean, the float, they all fit really nicely in one of these seats. Strings, not so much. So this is the first thing to observe. Strings are what we call, they are an object. An object would be like not primitive types. We can see a lot of them. We're going to see a lot of them. And you will actually be able to define your own objects. That's what we're going to do later in the course. But strings are a little different. And the first thing I want to mention is methods. Raise your hand if you've heard the word method before. Raise your hand if you've heard the word function before. Of course you have. Raise your hand if you're like, yeah, they're basically the same thing. Yeah, good answer. Yeah. So here's the simplest way I can explain what a method is. I'm going to go through this content in a second. A method is a function that operates on a specific instance of an object. You could think of it as a function where it has an implicit argument that you didn't actually have to add in your argument list, like print, right? So print, this is a function, right? The argument there, oh look, I use single quotes. The argument there is the string. That's the value I'm giving to the function, and that's what gets printed out. Remember, the arguments are the things I put in the parentheses when I call the function. A method is like a function, but I don't actually need to explicitly give it. All right, you know what? I'm just going to go through this, and then I'll come back to this. So here's a function. We've seen built-in functions. Print, this is a function, right? It's a function, nothing special. It's got a name. We give it some arguments, and then it does its thing, and it, whatever, right? Here's another one. Character is in. We wrote that, right? We wrote the function character is in. It returns a Boolean. Does the character exist in the string or not? We gave it two arguments, a and blah, and it's going to give me a Boolean back, right? It's a function. However, there are things called methods. They're very similar to functions, but they act on specific instances of objects. So here's an activity. I'm just going to do it, but feel free to follow along. But I'm just going to do it. I'm going to go here. Okay, you know what? I'm going to restart the runtime, so I've got a fresh runtime. Restart runtime. Yes. All right. All right, there. I created a string and I ran it. Okay, I'm going to go to the next cell. Now, I can use the print function. I called the print function. It took the argument, the variable. This is a string, right? if you're following along, here's what I want you to do. I want you to say the name of the string. Come on, this is, my God, what's happening? Oh no, did I lose the internet connection? Is anyone else not connected to the Wi-Fi? All right. Okay, there. I'm going to type the name of the function. Or sorry, no, not the name of the function, the name of the variable. That is a string, and I'm going to type dot. And then I see this pop up. This pop-up is just Colab showing me something. If you're using some other IDE, it would work similarly, right, with code completion. It's just showing me things that already exist. Every single one of these things in the purple boxes are methods. All right? But I'm going to use them a little differently. I want to find one that's going to be nice. Actually, here, who remembers using split? Raise your hand if you've ever used split. Yeah, that's a method. But did you know, like, what did that method do? Well, it split a string. But you didn't need to give those strings any arguments, or sorry, that split method an argument, but it still acted on the string that you told to split. Let me show you. Okay, I've got this hello world. And I run it, I see this. Okay? The method split didn't take any arguments, but there was this implicit argument of this is a string. The variable this is a string held the string hello world, hello space world. And when I told it to split, it was kind of like, imagine I would have called it like this. Right? Do you kind of see what I'm saying? Imagine there was a function that exists called split that takes a string and returns, the split version of the string. But that doesn't exist in Python. No. It's actually a method for strings that I would use like this. Okay? There are a lot of methods for strings. That was split. Let's capitalize. I'm wondering if it... Oh. Yeah, look at that. What did capitalize do? Good. It seems like it had a pretty good name. Yeah, it took the string hello world and made the first letter uppercase. Great. The function didn't take any arguments, but there was this implicit argument. There was a value that function acted on. It was the value hello world, the value of the specific string I told to capitalize. If I had another string, when I run this code, will this W get capitalized? No, because I didn't tell the string, this is also a string, to capitalize. I told this is a string to capitalize. So it's like a function, but there's an argument that you get for free, which is the instance of, it's the value of the thing that you're telling the method to act on. So yeah, there's a bunch there. Yeah, there we go. Here we go, yeah, upper. Upper, converted it to uppercase. Now, mind you, this is a string was left alone. This method returned a new string. Because remember, strings are, what's the special word we use? Immutable. You can't change them, which is a good thing. We like that. So a method is a function that's going to act on the instance of the object you're calling it on. So this is the instance of the object. This is a string. It's a variable containing some value. So that's an instance of a string. It's an instance of an object, because strings are objects. And then I'm calling the method that exists, upper, on that instance. So it capitalized that value. The hello world. Is that clear? At this stage, I don't want you to be experts on this, because you're not going to be. Right? Because now you're going to say, why would I have a function instead of a method and a method instead of a function? It seems kind of arbitrary. And you're kind of right. I mean, usually we write methods to go along with certain objects where it kind of makes sense to put them there, just kind of like a nice, keeping your code nice and tidy. If I have all these functions that I want for strings, why don't I just make them methods for strings so they're like connected to strings a little bit more? You know, it could do that, right? And someone might say, I hate methods, just write functions. Yeah, you're right. But Python's object-oriented, so we've got methods. And how do you know which one's which? How do I know if something's going to be a method or a function? Well, when I look at the code, I'll be able to know, was that a function or a method just by how it was called? Was it called on an instance? It was a method. Was it just a function call? It's a function. But how am I going to memorize what's a method and what's a function so later I know that that thing was a method, so I'm going to call on an instance? You're not. What you do is you just look it up when you need to. Make a string uppercase in Python. Oh, use the upper method. Don't try to memorize everything in the Python documentation. It's not going to happen. Anyways, I'll see you later.